On May 10, 2026, Jensen Huang stood before graduates at Carnegie Mellon University's 128th Commencement in Pittsburgh, Pennsylvania. He was not speaking merely as the chief executive of a successful technology company. He was speaking as a builder at the beginning of what he described as a new era of science, industry, and discovery. His message was direct. Do not wait for the future to arrive. Help create it. But how did a quiet engineering student become the leader of one of the most valuable companies in history? Born in Taiwan, Huang came to the United States as a child. At 16, he entered Oregon State University as a shy and introverted electrical engineering student. He later earned a master's degree in electrical engineering from Stanford University and worked at AMD and LSI Logic before co-founding NVIDIA in 1993. NVIDIA began with a focused mission: improve computer graphics. That sounds obvious today, but it was a dangerous business. The company faced failed products, fierce competitors, and moments when one incorrect decision could have ended everything. The first lesson is this: great companies are rarely built by predicting the future perfectly. They are built by learning faster than failure can destroy them. Huang developed a habit of first principles thinking. Instead of accepting how something had always been done, he asked what should be built using the conditions and technologies available now. That mindset transformed NVIDIA. The company did not remain only a producer of gaming chips. Huang recognized that graphics processors could perform enormous numbers of calculations in parallel. NVIDIA invested for years in accelerated computing, CUDA software, data centers, and artificial intelligence before the commercial opportunity was clear. For a long time, the strategy looked expensive and uncertain. Then AI reached its turning point. Today, NVIDIA technology helps train and operate advanced AI systems, powers scientific research, supports cloud computing, assists drug discovery, and increasingly guides robots, autonomous vehicles, factories, and industrial machines. By July 2026, NVIDIA's market value was approximately $4.8 trillion. The company reported $215.9 billion in fiscal 2026 revenue, followed by a record $81.6 billion in the first quarter of fiscal 2027. But those numbers are the result, not the central achievement. Huang helped transform a specialized product into infrastructure. A product solves one problem. A platform allows thousands of other people to solve problems its creator could never anticipate. CUDA and NVIDIA's broader ecosystem gave researchers, developers, startups, governments, and major companies a foundation on which to build. NVIDIA grew because its technology became useful to people creating the future. Huang's speech therefore carried a warning. Education and intelligence are not enough. Graduates must choose difficult problems, develop judgment, and act with urgency. Artificial intelligence will increase the power of individuals, but it will also shorten the distance between a new idea and new competition. Knowing something matters. Applying it matters more. Huang did not build NVIDIA through one miraculous breakthrough. He built it through decades of engineering decisions, failed products, repeated reinvention, and continued investment in ideas that initially appeared too early. That gives us another lesson. Being early is not the same as being right. A visionary still needs execution, timing, customers, capital, and a team capable of surviving until the world catches up. Conviction without learning becomes stubbornness. Conviction supported by evidence becomes strategy. NVIDIA's next chapter is already forming. Its Vera Rubin platform is designed for advanced agentic AI. Jetson computers and physical AI models are being developed for robots and autonomous systems. Omniverse technology helps companies simulate factories and physical environments before building them. NVIDIA is also expanding into healthcare, telecommunications, vehicles, national AI infrastructure, and space computing. Yet enormous success creates enormous responsibility. AI infrastructure consumes energy, concentrates power, and can support both scientific discovery and harmful control. NVIDIA's future will depend not only on faster processors, but on whether its systems become efficient, reliable, secure, and genuinely beneficial. Huang's story teaches 5 lasting principles. Start before certainty arrives. Work on problems difficult enough to matter. Treat failure as information, not identity. Build tools that enable other people. And stay close to the mission after success creates distractions. The real question is not whether you can become the next Jensen Huang. It is whether you can recognize an important change before it becomes obvious.